Okay, sir.
And let's start with the first problem. So here we first explain the problem statement, then we discuss about the approach, and then we discuss the time and space complexity.
Okay, sir. So in first question, we basically given a matrix in which we start from starting position I00, and then we have to move. We have given four commands: up, right, down, left, and we will be given these command in a array or vector. And then following these commands, we have to tell the state like the last state which till which we go. So basically, what I have done in this code is that initially I taken x equal to 0, y equal to 0, two variables. Then I iterated over the command array, and then according to the word like up, I decremented. For left, I basically moved according to the command, and then in the last I printed by using the formula that was given in the first line I star n plus j. So that was all approach according to me.
Okay.
Should I stop sharing my screen?
So anyone has any doubts in this? Like, should I take up and start explaining this?
No one.
Okay. Uh, so let's go to the second question. Okay. Like, second question, like Tarun, you did.
Yes, sir. But yes, sir.
Uh, so the first question I would just briefly explain. So you make the matrix, you follow the instructions, and you go to like as instructed in the question, and then after reaching the final cell, you just calculate the value of the final cell using that formula, and you return that value. Okay, it's very easy. So yeah, Tarun, you can start with the second one, or anyone else wants to take it up like the second one. Sakshi or like Bharat, Chaitan, Arun. Arun will explain the third one. Okay.
Okay, Anish.
Second one, anyone out of three. Tarun has already done one, so I am preferring any other person. Okay, cool. Tarun, you can go ahead. No one is really interested.
Okay, sir. So basically, sir, in this question, we have to count the number of good nodes. A good node will be that node whose subtree that will be rooted at its children will have equal children. Means its subtree will have equal children, i.e., all the nodes below it will be equal in size. Am I clear with the
Yes.
question? So basically, what we will do, we will apply DFS and iterate recursively in the question, and from and follow the top to down approach. And from last, we will calculate the size of the array and return it to the its previous one, like its parent node, to its parent node. And finally, we will check if the count of both the or that what how many children it have. If the size of all the children are equal, then we will tell that it is a good node or else not.
Okay.
So am I clear with my
So
approach?
you can just explain the implementation also a bit.
Okay, sir. So firstly, I have created an adjacencies list for traversing through the DFS or applying DFS. It is an undirected adjacency list. After that, I have called for DFS, and
So just explain the part where you have like made a calculation of the size of the subtree.
okay, like here in the DFS section itself, I have made, I have calculated the value of the children's like this. Like I have stored this value in temp for every node for which I will traverse. Like for node one, it have two children, 4 and 3. Then when I will iterate from for 1, then I will store this in single temp in temp value, and then will store it in val vector, and then for another time, next time when I iterate through this next node, then I will store it in next node, in the next, like that. I have stored it in the val vector. That's awesome.
Anis, if you are comfortable, can I explain?
Just a moment. Okay. Yeah, so you want me to explain this part, right? Hello? Hello?
Hello, Anis.
Yeah,
Hello.
yeah.
Yeah, Anis, I'm just saying, like, if you are comfortable, I can share my screen and explain it.
The third one, right?
Yeah, the if it
Just a
is
moment.
second one
Like
or third one.
let's see that if anyone has any problem in the second problem. Okay. So the second problem is clear to everyone. Hello. Okay. So I would just quickly just tell what you need to do in the second one. Okay, like for people who haven't understood. Okay. So let's say you have a tree. Okay. So every time in DFS you keep a count of the subtree nodes. Okay. So it can be a simple thing that you write the DFS, you take the node and you take the parent. Here you call the DFS with the children, okay, or the child, and the parent will be X. So you will iterate over all the child of X, okay, and call DFS, okay, and you will also count the subtrees inside this child, okay, so and return it. So let's say the length of or the size of the subtree starting from this node child is stored in this subtree variable, okay. So let's say you have a variable called total subtree or total sub. So you keep on adding this value of subtree to total sub, and you initialize it as 1 because this node X is also included in the subtree, okay. So and then you check that whether the subtree lengths or the subtree sizes are equal. If it is, you increase the answer by 1, and you also return the length of the subtree from this node, okay. So this is the basic implementation, okay. The idea is very simple, that you keep a track of the subtrees, and this is how you implement on a high level basis, okay. Yeah, Arun, you can start with the third one.
Okay, Anis. Let me share the screen. Yeah, yeah, Anis, is my screen coming?
Yes.
Yeah. The question is something like find the count of monotonic pairs, right? The question is basically it is a DP question, dynamic programming question. So it is like I have solved using like a top-down approach, like recursion plus top-down approach. The question is basically saying you can say like uh, it is basically we have to find all the combination with respectable with the condition. Like the condition is saying that if the array1 and array2, here in the example we can go there, like the array1 should be increasing and the array2 should be decreasing, okay. So and the array of like each index plus array2 of each index, the sum of these two is equal to nums of that index, okay. So what I have done here, I took a like first I have taken a recursion function here, that one is helper. Okay, so first I have taken a previous value. Like this previous value indicates like in the array one what we have taken before. Like for the let's say if we are at the index one, so at the index one we are checking the what value we have taken in the index 0, okay, for array 1. So here I have taken a previous one, means previous one is indicating that the value we have taken for array 1. And what I have taken, though I have taken, here we can also take a previous two, but for optimize purpose, for optimize the space complexity, I have optimized these things. Like I have taken a previous equals to 102, and what I have done, the previous two equals to norms of index minus one minus previous one, means we are like finding the previous two. Let me explain here. Let's say the value is 1 2 3. Okay, so first in the array 1, the basically this is norms, okay, and this is array 1. Okay, let's say in the index of 0 we can take 0, okay, and another value and another value for array 2, for array 2. Okay, so here we can take one, and this is something like that, or we can take like this one, something like that. And here the we have a we have given the condition that array of 0 means array of previous index should be greater than the current index. So here we can't take this 0, means we can't take here 0. Okay, so this condition may be, this is not satisfying our condition for this second one. Okay, so what we are taking, first we are taking 0, and the second one is 1. Then what we are going to do, then we are iterating through the second index. Okay, so in this way you can do it. Like we are taking this, like we are taking the previous one, and we are going up to that norms of index, means we are checking all the possibility here. Okay, and we are finding the second number here, and if it is satisfying our condition, then we are going to add to our answer. Okay, and in the last, if it is coming to if all these things are satisfying for all these index, our rules are satisfying, then we are going to return the one, means we are reaching to the last index, then we can return like we have find a solution here.
Okay,
like
okay. But I think most of them have not got the concept.
Yeah, I think so.
Okay, so okay, no worries. Like you did it right.
Sorry.
You did the right algorithm. So I would just explain it a bit more. Okay, just give me. Is my screen visible?
Yes, sir.
Okay. तो सबसे पहले like what they have told in the first place. Okay, like Arun, watch how I explain. This will be needed when you are explaining in a interview or a similar thing. Okay, so what they have told that they have a array called nums, right? Yes, they have a array nums. They have another array arr1 and they have another array arr2. Okay, so they tell you that arr1i plus arr2i should be equal to numsi, right? Come on, guys. Yeah, okay, and there is one more condition, arr1i should be greater than equals to arr1i minus 1, and arr2i should be less than, right? Yes, should be less than equals to ARR 2 I minus 1, right?
Yeah.
So now what we know that nums, now understand this mathematical derivation. Nums I is equal to ARR 1I plus ARR 2I, right? Now nums 2, nums, let's say I, let's say another j, is equal to ARR 1j plus ARR 2j. Okay. Also, like if I write this, so nums I, also I can write it like this: ARR 2j or 2I is equal to nums I minus ARR 1I, right? I can write ARR 2 like this. Okay. Now if I substitute the value of ARR I into this equation, okay, so what does it tell me? That nums I minus ARR 1I should be less than equals to nums I minus 1 minus ARR 1I minus 1, right? So now if I bring this nums minus 1 to this side, so nums I minus nums I minus 1. Now this inequality sign will remain the same because every number or every element is positive, okay? And when you exchange positive numbers, the inequality sign remains the same, okay? So it says that this difference should be less than equals to ARR 1I minus ARR 1I minus 1, okay? So if I simplify this, so ARR 1I minus ARR 1I minus 1 should be greater than equals to this difference of nums I, okay? So I can tell that, and this is fixed, right? We are given the array nums, so this will be fixed. So I can tell this as let's say x. So x is given to us, okay? So for every I, this should be greater than equals to x, okay? So this we have derived. Clear this part? Now I say that I will define a dp, let's say dp ij, where I will say that I have considered the first I elements. So I have considered the first I elements, and the last element of ARR 1 is j, okay? So ARR 1I is equal to j. So this is my dp state, okay? So now what, how will I make the transitions? So dp ij will be equal to the summation of dp I minus 1. So the difference between the ith index and the I minus 1th index should be greater than equals to x, okay? So it will be the summation of dp I minus 1 j minus x, or let's say this is k, okay, where k will range from 0 till j minus x, okay? This part is clear? Why j minus x? Because the difference between the consecutive indexes should be greater than x. Like the difference between the I and the I minus 1th index should be greater than x, where x is the difference between nums I and nums I minus 1, okay? So if I have to make the last element, so if I have to make ARR 1I as j, so ARR 1I minus 1 should be less than equals to j minus x. Okay, this should hold true to maintain this condition. Okay, this is understandable? Tarun, Sakshi, Chaitanya, Arnav has got it. Arun has done it. Okay, Chaitanya. Okay, so to maintain this condition, error I minus 1 should be less than equals to j minus x. Okay, so we will take all the elements from 0 till j minus x. Okay, so this is the transition state. So now it's very easy to code. Tarun, अब हो जाएगा ये problem?
यस सर, एग्जांपल ले सकते हैं.
Example, okay. तो let's say there is an array called वही एग्जाम्पल ले लेते हैं पहले का 2 3 2. ठीक है, 2 3 2. ओके, तो मैं ये बोल रहा हूँ लाइक लेट्स से आई एम एट द फर्स्ट इंडेक्स. ओके, सो what will be x is 1, right? 3 minus 2, num psi minus 1. ठीक है,
यस
तो अब मैं ये बोल रहा हूँ ARR 1 को ARR 1 and ARR 0 ARR 1 0 should have a difference of greater than equals to 1. ओके, ठीक है, मैं ये बोल रहा हूँ. तो इफ ARR 1, लेट्स से इफ आई एम कंसिडरिंग, सो मैं क्या बोला, DPIJ रिप्रेजेंट्स कि मेरा लास्ट एलिमेंट J है. ठीक है, तो अगर लेट्स से मैं ये स्टेट कंसिडर कर रहा हूँ DP1 2. ठीक है, तो मेरा ARR 1 को मैं 2 पकड़ रहा हूँ लाइक. ओके, ठीक है, तो अगर मैं लास्ट एलिमेंट को या सॉरी दिस एलिमेंट को अगर मैं 2 रखना चाहता हूँ, तो दिस एलिमेंट इन ARR 1 should be less than equals to 2 minus x. x यहाँ पे 1 है, so 2 minus 1. तो the first element of ARR should be less than equals to 1. ठीक है, नहीं तो ये कंडीशन मीट नहीं होगा, दिस कंडीशन. क्लियर है तरुण?
ओके सर.
नहीं समझा तो एक बार फिर से लाइक 2 मिनट लो और समझ लो. मैं ये बोल रहा हूँ लाइक यहाँ तक डेरिवेशन समझ में आया ना, ये डेरिवेशन कैसे आ रहा है?
यस सर, यस.
तो मैं यही बोल रहा हूँ कि डीपी स्टेट हमने क्या डिफाइन किया कि डीपी आई जे रिप्रेजेंट करता है कि मैंने आई एलिमेंट्स तक लिया है एंड मेरा लास्ट एलिमेंट ऑफ ARR 1 इज जे. ठीक है, तो अगर लास्ट एलिमेंट J है ARR 1 का, लाइक द ith एलिमेंट इज J, तो I माइनस 1th एलिमेंट को J माइनस एक्स से कम होना पड़ेगा, राइट? अदरवाइज जो दूसरा एरे है ARR 2, वो कंडीशन मैच नहीं होगा कि ARR 2 डिक्रीज होता जाएगा अगर ये कंडीशन मैच नहीं हुआ तो, राइट? और ये कंडीशन कैसे हम लोग ऊपर डिराइव किया है. ओके, तो we will consider, so coming back to the transition here. Okay, so if we want to calculate the value of dpij, we will take all the values of dpi minus 1 k, where k ranges from 0 to j minus x, क्योंकि k will be less than equals to j minus x, so k can go up to 0 to j minus x. ठीक है, क्लियर है ट्रांजिशन स्टेट सबका? साक्षी, चैतन्य, वसीम, अरुण, भारत. ओके, अब तो हो जाएगा. लाइक वी हैव द स्टेट्स, वी हैव द ट्रांजिशन स्टेट्स. ओके, सो वेरी सिंपल है. फॉर लूप चलाओ I 1 to n. एक और नेस्टेड फॉर लूप चलाओ J के लिए फॉर 1 to, कब कहाँ तक जाएगा ये? कम ऑन गाइस, कहाँ तक जाएगा? कंस्ट्रेंट क्या है? Constraint is 1000. So it will be max of nums. ठीक है, dpij क्या होगा? dpij is equal to summation of dpi minus 1 j minus x. ठीक है, सॉरी j माइनस एक्स नहीं, 0 to j माइनस एक्स. ठीक है, तो अब ये जो 0 to j माइनस एक्स है, इस पार्ट को तुम जल्दी करने के लिए, लाइक टू डू इट फास्टर, यू कैन maintain a prefix sum, or let's say a variable which stores the sum. Okay, so let's see how do we do this. So let me erase this. Okay, so first of all, for every j, let's calculate the value of x. Okay, so x is nums I minus 1, right? This is our x. Okay, and we, let's say, maintain a prefix variable which is initialized with 0. Okay, so prefix will be added by dp of I minus 1 j minus x. Okay, now if j minus x is obviously positive, agar j minus x 0 se kam hai, we are not adding anything. So we also check that if j minus x is greater than equals to 0. Okay, and then we are adding dpij is equal to this prefix value. Okay, and then we return the sum of dpn. Okay, this is the how you do the second part of the problem. So if you didn't understand this part, let me explain a bit more in detail. So what did I say? dpij is summation of dpi minus 1 k, where k starts from 0 to j minus x, right? So every time we have to calculate the summation from 0 to j minus x. Okay, so this will take more time if we calculate it for every time for every j. Okay, so instead of calculating it every time, so I am storing a prefix variable that will add, or that will keep on adding all the values from 0 to j minus x. Okay, so that we don't have to calculate the values of 0 to j minus x every time. Okay, so this part is clear. Tarun, Sakshi, Chaitan has understood. Bharat. Okay, and then at the end we are returning the sum of dpn. Okay, why the sum? Because we can end with any value. Okay, like the last element of arr 1 can be anything, so we have to take the sum of all the possible cases. And obviously we will be adding mod, because question mein likha hai ki we have to return the value of the sum mod, that 10 to the power 9 plus 7. Okay, and also here also, while adding, have the modular operation. Okay, so that I am not explaining, I am trying to explain you the intuition here. Okay, so this is how you do this. You can optimize the space also. Just think for that, like how you can optimize the space. I will give you a hint. So while calculate, and this is optional. Okay, this is not necessary, I am just giving you a hint as this is optional. Okay, so what is the space complexity here? So n into max of the value nums, right? So you can reduce it to max of nums. Say how? So understand one thing, that dpij, or let's say dpi, the array dpi depends on dpi minus 1, right? So we only need to store the ith term or the ith array and the I minus 1th array. We don't need to store I minus 2, I minus 3, all of those. Okay, so we only need to store the current array or the current state and the previous state. Okay, so you can reduce it to 2 into max of nums. You can get rid of the first dimension if you want. Okay, but this is optional. Jo constraints hai, that will pass if you do what I just said. Okay, like what I just explained till here. Okay, the next part is optional, you can skip that if you didn't understand. Clear? तरुण समझ आ गया ना, लाइक ये अब सॉल्व करना है, लाइक गो एंड अब सॉल्व दिस. एंड Arun, you understood, right, how you should optimize? Just you need to use that prefix sum.
Correct. We can optimize the space, right?
Yes, we can optimize the space, and most importantly use that prefix variable, so that you don't have to calculate the sum again and again.
Okay, but it is question number 3. But for question number 4, we have other approach, right?
This is the question number 4 only, like the second part. This will pass the question 4 as well.
Okay.
So I explain the fourth part, like both of them. Like if you do this, it will pass both 3 and 4, because the time complexity here is O of n into max nums, right? It will fit into the constraints. So it is 2 into 10 to the power 6, the time complexity.
Okay. 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 Got it.
You understood the approach, right?
Yeah. Yeah. I got it. Somehow, we are only depending upon the previous one, right?
Yes.
So we can optimize like that.
Yes. So you can have it like this. Instead of storing dpi, you can store it like dpi mod 2. Okay. So you will only store the first current state and the previous state.
Yeah. Correct. Correct. Okay. Okay. Got it.
So this part is optional. Even if you, let's say, use uh, n into max of nums space, it will pass. Yeah.
Anis, can you explain me the time complexity? How we are reducing the time
We are
from
reducing
question
the
3 to question 4?
we are reducing the time by using this prefix variable. So in question 3, you can afford calculating the sum from 0 to j minus x every time, okay? But in question number 4, you will have to maintain a prefix variable so that you
Okay.
calculate the sum on the go and you don't calculate it from 0 every time.
Okay.
Okay. So you are keeping a prefix variable which will calculate the value. So let me explain how the prefix variable is working. So prefix variable, or let's say this variable prefix, will maintain the sum from 0 to j minus x every time. Okay. When j is ranging from 0 to max of a. Okay. So this prefix variable will maintain the sum from 0 to x every time. So let's say if you have the prefix variable maintained till j, so when you are calculating for j plus 1, you simply have to add prefix is equal to prefix plus j plus 1 minus x. So now prefix is maintained from j 0 to j plus 1 minus x. Okay, so this we need to add for the j plus 1th index.
Anis, we can take a can you take a sample example so that it will be easy? Can you take it length of 3 variable?
So
Like
let's say
we can
2
take
3
a.
and 2. Okay, so let's say 2 3 and 2.
Huh?
Okay, so dp, let's take this part. Okay, so what will be the
Mhm.
value of dp12? Okay, so dp12 will be the summation of dp0 1 plus dp00, right? Because x is 1 here,
Okay.
right? So
Mm-hmm.
k can range from 0 to 1, right?
Yeah. Correct.
So what I'm trying to tell here is that the prefix variable will not calculate these two again. Okay, so when I am at, let's say, when I am calculating dp11, okay, so I need the value of dp00, right?
Mm-hmm. Yeah. Correct.
So in this step only, like I would have this value added to prefix, so prefix will store dp00, okay, right? So when I am coming from deep, when j is incremented from 1 to 2, so I'm calculating dp12, so prefix already has the value of dp00 inside it. Okay, so I don't have to add it again. So I just need to add dp I minus 1 j minus x. Okay, so I just need to add dp01 and I get the whole value I need for dp12. Got it?
Mm-hmm. Yeah. Yeah. Got it.
So let's say now if I have to calculate the value for dp13. Okay, so what will be my value for dp13? It will be
DP zero
dp01
zero one zero. Yeah,
00
01 plus
plus
yeah 02.
dp02, right?
Yeah.
But my prefix already has the value of 00 and 01. So I just need to add the value of dp02, which is dpi minus 1 j minus x, and I will have the whole value.
Okay.
Okay,
Okay.
so we
Okay.
don't have to
Yeah.
add the whole thing again and again. I am storing the previous terms in prefix every time, so that I just need to
Mm-hmm.
add this value to get my answer. Got it?
Okay. Yeah, got it.
Cool. Cool. Any other questions?
Hi, so I want to understand the intuition behind getting the mathematical condition that we discussed, right? Nums
Okay.
2 of I minus,
Okay.
nums of I minus nums of I minus 1 is greater than equal to
This part.
array 1 of I minus array 1.
This part,
Yeah,
right?
like I understood this condition, but
You want to know
like
the thought process.
what is the observation that you have went through
Okay,
to get the second derivation?
so one thing you have to understand, DSA is very much of hit and trial. Okay, so whatever you have, first you write it down. Okay, so first when I was solving, so I first wrote down this equation, which was very obvious. Okay, then I would tell how I got it. So I wrote this statement, okay, or this equation, this first equation, and then I wrote this equation. Okay, and then I wrote this part, that uh, ARR1 ARR1i is equal to nums I minus ARR2i. Okay, so it was more of hit and trial, to be very honest, and in DSA you will have to do a lot of hit and trial as well, and when you have experience you automatically get an idea of what needs to be done. Okay, so first I wrote that nums I is equal to array 1i plus array 2i. Okay, now the most or the most useful observation that you need to make, or I would say the things you need to do in such cases, is to fix one of the things. Okay, so if I fix ARR1, can I find the value of ARR2? Okay, the answer was yes. So if I fix the value of ARR1, I would get the value of ARR2. How? ARR2i is equal to nums I minus ARR1i. Okay, clear till here? So your first thought should be like fixing as many things as you can. Okay, or eliminating as many variables as you can. So I wanted to eliminate the uh, value of ARR2. I only wanted to think about ARR1. Okay, so now since this is fixed, and if I fix this value will automatically be calculated. I don't need to think about this. Okay, now I saw that there is one more condition, that ARR 2i should be greater than equals to ARR 2i minus 1, right? Sorry, less than equals to. Okay, and then I substituted the value of these two here, and I got that value or that equation. Okay, so always try to eliminate as many variables as you can in a equation. Okay, so that your time complexity gets reduced. Okay, so if there were two variables, our time complexity would have gone to n square. Okay, because we have to iterate over the values of both ARR1 and the values of both ARR2. Okay, so when you eliminate one of them, you just have to iterate over the values of ARR1. Are you getting what I'm trying to say?
Yeah. Okay.
So try to eliminate as many variables as you can. And if I want to eliminate ARR2, I have to calculate the value of ARR2 in terms of ARR1. Okay, so I have to substitute the value of ARR2 using the value of the rest of the variables, so that it's not independent. Okay, so that was the intuition.
Okay.
Cool. I think that should be it. Any other questions? Otherwise we can stop. Cool. Then upsolve the questions. Okay, that's the most important part. And don't forget that upsolving questions which are outside your comfort zone will help you to increase your rating. Okay, so I think that's it for this session. See you in the next session. Bye.